Alright, in this video we're going to be looking at divisibility. Here we begin in a chapter on number theory. So the first thing we'll look at is divisibility and the divisibility rules. And we'll talk about what divisibility is like. And what it is, by the way. An integer is even if its remainder is 0. Okay? So an even number means that the integer, when it's divided by 2, will give you a remainder of 0. Otherwise, it's odd. And here we can say that 3 divides 18, which is written like this. 3 with the vertical bar, and then 18. So that means 3 goes into 18. 3 divides 18, because you're going to get a remainder of 0 when you divide 18 by 3. So that means 3 goes into 18 6 times with a 0 remainder. So we can say 3 does divide 18. Likewise, b divides a can be written as this. B with the vertical bar, then A. We also say that 3 does not divide 25. And it's written like this. The vertical bar with a small slash. Meaning 3 cannot go into 25 evenly because we're not going to get a remainder of 0. In other words, if we divide 3 into 25, we're going to get 8 with a remainder of 1. In general, if a is a non-negative integer and b is a positive integer, then we can say that a is divisible by b, or b divides a, if and only if the remainder is 0, when a is divided by b. That's a general rule for divisibility. Our definition is this. If a and b are any whole numbers, then b divides a, written with b as with a vertical bar, then a, if and only if there is a unique integer called q, such that a is equal to b times q. And if b does divide a, then we can say that b is going to be a factor or a divisor of a, and then a will be a multiple of b. So in other words, if we have, let's say, 5 divides 30. Here, 5 does divide 30 because 5 goes into 30 6 times. That means that the 5 will become a factor of the divisor, which is 30. So 5 would be a factor of 30. And also we can say that 30 is a multiple of 5. Let's look at some examples here. And we're going to classify each of these as true or false. In part A, you got negative 3 divides 12, which is true because we can divide negative 3 into positive 12 to get negative 4. Part B, 0 divides 2. That's a false statement because there's no number multiplied by 0 that's going to give us an answer of 2. Part C, 0 is an even number, which is true. Part D, 8 does not divide 2. That's true, because we cannot divide 8 into 2 to get a whole number. Part E, for all whole numbers, A, 1 divides A, which is true, because I can get any whole number, doesn't matter whether it's 1,000,000, 1 divides 1,000,000. Or 50,000, 1 divides 50,000. Or 80, 1 divides 80. Part F, for all non-zero whole numbers a squared divides a to the 5th. Because I can find out what expression multiplied by a to the 2nd that will give me a to the 5th, which is in this case a to the 3rd power. So if you recall, when you multiply powers of the same base, you add your exponents. And G, 3 divides 6n. Any integer that I assign to n multiplied by 6 is going to be a factor of 3, so that's true. Part H, 3 does not divide the sum of 5 times 7 times 9 times 11 and 1. That's true. Because if we take 5 times 7 times 9 times 11. That would give you 3,465. And if you add 1, you're going to get 3466. And 3 would not divide 3466. You're going to get a decimal. So that would be a true statement. Also, 0 divides 0 for all integers n. That's going to be false because of the fact that 0 divided by 0 would be undefined. Okay. Let's look at some properties for division. For any whole numbers a and d, if d divides a and n is any whole number, then d divides n times a. In other words, to put this into perspective, if d is a factor of a, then d is a factor of any multiple of a. Like what I have here is 7 times 21. I mean 7 divides 21, because 7 goes into 21 3 times. Take a multiple of 21, you're going to get a multiple of 21, which is 63. 63 is a multiple of 21. That means that 63 will be a factor of 7. So 7 also divides 63, because 63 is a multiple of 21, which divides 7. Okay, for any integers a, b, and d, where d is not equal to 0, part A is this. If d divides a and d divides b, then d will divide the sum of a and b. Here's an example. 2 divides 8, that's true. 2 divides 10, that's also true. Then it's also true that the sum of 8 and 10, which is 18, will also be a factor of 2, which it is. Part B, if d divides a and d divides b, well, d does not divide b, I'm sorry, then d will not divide the sum of a and b. Here's an example. 2 does divide 8. 2 does not divide 7. So if I add 8 and 7 together, 8 and 17, no, 8 and 7 together, that would give you 15. 8 plus 7, that's 15, I'm sorry. And 15 is not a factor of 2, so 2 will not divide 15. Alright, part C, if d divides a and d divides b, then d will divide the sum of the difference of a and b. In this case here, 3 divides 21, 3 does divide 9, so do 21 minus 9, that will give you 12, which is a factor of 3. So d will divide the difference of 21 and 9. And finally, if d divides a and d does not divide b, then d will not divide a minus b. Well, 3 divides 21, but 3 does not divide 8. So subtract 21 minus 8, you're going to get 13, which is not a multiple of 3. So 3 would not divide 13. So 3 won't divide 21 minus 8. Okay, so those are the properties of division that we can use in these examples here. Here we want to classify as true or false, where x, y, and z are whole numbers. Look at part A. If 3 divides x and 3 divides y, then 3 will divide the product of x and y. That's going to be true, because we know, let's say for example, 3 does divide 6, 3 divides 9. If we take 6 times 9, that's going to give you 54. 54 is a multiple of 3, so 3 would divide the product of 6 and 9. Now in part B, 3 divides the sum of x and y. If that's the case, then 3 divides x and 3 divides y. That's false. Let's say in this case here, 3 divides 7 plus 2. Well, 7 plus 2 does give you 9, which is a multiple of 3. Break this up. 3 divides 7 is false. 3 divides 2. That's also false. Okay? So this statement here in its entirety is false. Part C. If 9 does not divide A, then 3 does not divide A. That's going to be false. Because in this case, 9 does not divide 6. But not necessarily what it holds true for 3, because 3 divides 6. Because 3 goes into 6 2 times. So 3 not dividing 6 will be false. So this statement, part C, is false. We'll talk about some divisibility rules here in this particular part of this video. Sometimes it is useful to know if one number is divisible by another just by looking at it. For example, to check the divisibility of 17 times 1734 by 17, we need to know that 1734 is equal to 1700 plus 34. We know that 17 divides 1700 because 17 divides 17. And of course, 17 will divide any multiple of 7. And furthermore, 17 does divide 34. Therefore, we can conclude that 17 divides 1734. Okay. Another method of checking for divisibility is using the integer division button, or the INT division button on the calculator. Some calculators do have integer division as a button that you can use to divide, and it will give you the quotient and the remainder. So if you want to do 1734 divided by 17, you'll type in 1734, then you'll press the INT division button and then 17, and then hit equal. You'll get this display where the Q is your quotient, which is 102. The R is the remainder, in this case is 0. So you can see that 17 divides 1734 using the calculator. Now let's talk about divisibility test for various numbers. A whole number is divisible by 2 if and only if its units digit is divisible by 2. Okay, so if the ones digit is a 0, 2, 4, 6, or 8, then that means that that number itself will be divisible by 2. So you look at the ones digit when you're dealing with a divisibility test for 2. For 5, a whole number is divisible by 5 if and only if its units digit, or the last digit, is divisible by 5. In other words, the last digit has to be a 0 or a 5. And then a whole number is divisible by 10 if and only if its units digit is divisible by 10. That means the last digit must be a 0. That's the only way a whole number will be divisible by 10. The last digit must be 0. A whole number is divisible by 4 if and only if the last 2 digits in the number represent a number divisible by 4. You look at the last 2 digits in that number. Those last 2 digits must be divisible by 4. Then a whole number is divisible by 8 if and only if the last 3 digits of that whole number represent a number divisible by 8. So it's going to be the last 3 digits that you'll be looking at to determine divisibility by 8. Here's some examples. You want to determine if 97,128 is divisible by 2, 4, and 8. Well, 2 does divide 97,128 because 2 divides 8. Look at the last digit. It's an 8. It's divisible by 2. So the whole thing, 97,128, is also divisible by 2. 4 divides 97,128. Look at the last 2 digits, which is 28. 28 is a multiple of 4. We can divide 4 into 28 evenly. So 97,128 is divisible by 4. And then 8 divides 97,128 because you look at the last 3 digits, 1, 2, 8. 128 is divisible by 8 because I can divide 8 into 128. And that's going to give me, I believe, 16 times. 8 goes into 128 16 times. So in this case here, this number, 97,128, is divisible by 2, by 4, and by 8. Now what about this number, 83,026? Is it divisible by 2, 4, and 8? Well, it's divisible by 2 because the last digit is a 6. It's not divisible by 4 because the last two numbers, the 2 and the 6, 26, is not divisible by 4. And it's not divisible by 8 because 0, 2, 6, that's the last 3 numbers in the 3 digits in this number. Well, we can say 26, that's not divisible by 8. Okay, so 83,026 is only divisible by 2. And here's a Venn diagram for the divisibility rules for 2, 4, and 8. You got numbers divisible by 8. If a number is divisible by 8, then it's also divisible by 4. If the numbers are divisible by 4, then it must be divisible by 2 as well. Now, you may have a number divisible by 2, but not necessarily divisible by 4, like the number 10. 10 is divisible by 2, but not divisible by 4, nor by 8. Okay, here's some more divisibility tests. This one is for 3 and for 9. A whole number is divisible by 3 if and only if the sum of its digits is divisible by 3. So you'll take the sum of the individual digits in that number. That sum must be divisible by 3. And then a whole number is divisible by 9 if and only if the sum of the digits of that whole number is divisible by 9. Again, you take the sum of the individual digits in that number must be divisible by 9. Well, the sum must be divisible by 9. Let's take a look at this one. Determine whether 1,002 is divisible by 3 and 9. Here it's divisible by 3 because if you take the sum of each individual digit in 1,002, 1 plus 0 plus 0 plus 2, that's equal to 3. 3 is divisible by 3, so 1,002 is divisible by 3. But here, the sum of the digits here is not divisible by 9. In other words, 9 can't go into 3 evenly. So 9 would not be divisible by, 1,002 is not divisible by 9. It's only divisible by 3. Determine whether 14,238 is divisible by 3 and 9. Okay, it's divisible by 3 because if we add the individual digits in this number, 1 plus 4 plus 2 plus 3 plus 8, you'll get 18. 18 is divisible by 3, so 14,238 is divisible by 3. Also, it's divisible by 9 because that sum that we came up with is 18. 18 is also divisible by 9. So 14,238 is also divisible by 9. So we can see that 14,238 is divisible by both 3 and 9. Take a look at this example. The store manager has an invoice for 72 calculators. The first and last digits on the receipt are illegible. The manager can read this, and you can see there's a box and then 67.9 and a black box behind it. What are the missing digits, and what's the cost of each calculator? Okay, let's look at this. Here we're going to let the missing digits represent X and Y, so that the number will be this, X67.9Y dollars, or X679Y cents. Because 72 calculators were sold, the amount must be divisible by 72. And because 72 breaks breaks down to 8 times 9, the amount is divisible by both 8 and 9. So for the number on the invoice to be divisible by 8, the 3-digit number 79Y must also be divisible by 8. Okay? And there's only one number that's divisible by 8. In this case, that would be 792. Divide 792 by 8, you'll get 99. So the Y must be equal to 2. That means the last digit has to be a 2. And because the number on the invoice must be divisible by 9, that means that 9 must divide the sum of the individual digits. In this case, that's the x plus 6 plus 7 plus 9 plus 2, or x plus 24. 3 is the only single digit that will make x plus 24 divisible by 9. So x must be equal to 3. So the number on the invoice must be $367.92. And if you take $367.92, divide that by 72, that would be equal to $5.11. So each calculator must have a cost of $5.11. Okay, here's some more divisibility tests here. Let's look at the number 11. A whole number is divisible by 11 if and only if the sum of the digits in the places that are even powers of 10 minus the sum of the digits in the places that are odd powers of 10 is divisible by 11. And we're going to look at an example of just that very shortly. Because this divisibility test for the number 11 is kind of tricky because you have to look at the sum of the digits in the places that are even powers of 10, subtract that minus the sum of the digits in the places that are odd powers of 10. That difference must be divisible by 11. And then an integer is divisible by 6 if and only if the whole number is divisible by both 2 and 3. Okay? Because 2 times 3 does give us 6. And here's some examples of just that. Let's say we have the number 57,729,364,583. This one has too many digits for most calculator displays. Determine whether it is divisible by each of the following. Okay, look at part A. Is this divisible by 2? No, it's not. The last digit is a 3. It's not ending in 0, 2, 4, 6, or 8. Part B. Is that number divisible by 3? The answer is no. Because if I add 5 plus 7 plus 7 plus 2 plus 9 plus 3 plus 6 plus 4 plus 5 plus 8 plus 3, the sum of the individual digits, that gives me 59. 59 is not divisible by 3, so no, 3 does not divide into this number. What about 5? Easy. That answer is no. The last digit ends in 3, does not end in 5 or 0. Part D. By 6. The answer is no. If it's not divisible by 2, or if it's not divisible by 3, it's automatically not divisible by 6. It must be divisible by both 2 and 3 in order for it to be divisible by 6. Part E. Is this divisible by 8? It's no. Take 583, which is the last 3 digits in that number, divide that by 8. It's not divisible by 8. You're going to get a decimal. Part F. Is it divisible by 9? Again, the answer is no, because the sum of the digits was 59, and it's not divisible by 9. What about by 10? It must end in 0. It doesn't, so it's no. What about 11? Here's how it's divisible by 11. I'm going to add the sum of every other digit in this number. 5 plus this 7 plus 9 plus 6 plus 5 plus 3. If I add 5 plus 7, that's 12, plus 9, that's 21. 21 plus 6 is 27. 27 plus 5 is 32. 32 plus 3 is 35. And I'm going to minus the remaining digits here. The 7, the 2, the 3, the 4, and the 8. 7 plus 2 is 9, plus 3 is 12, plus 4 is 16, 16 plus 8 is 24. Subtract 24 from 35, you're going to get 11. And 11 is divisible by 11. So that means that entire number, 57,729,364,583, is divisible by 11. Okay, that's how we use a divisibility rule to determine whether that number is divisible by 11. Okay, that will conclude this particular section on divisibility.